Every night, as the world grows quiet around you, the universe continues its soft unfolding. Somewhere in that silence, billions of years of gentle history drift like slow tides, carrying the stories of stars, oceans, and the first breaths of life. Tonight, you're stepping into that quiet timeline, one shaped not by chaos but by calm rhythms that have echoed since the beginning of time. Imagine the universe before sound existed, a place where stillness held everything. The first light, the first clouds, the first whispers of life. Nothing rushed, nothing forced its way forward. Every transformation arrived with patience, guided by soft physics and slow evolution. This journey invites you to feel that same calm. With each section, you'll drift deeper into the universe's quiet moments, continents rising in silence, oceans appearing as gentle mists, early life shaping itself through soft cooperation. Each moment is a reminder that the greatest changes often begin quietly. As you listen, let your breath match the pace of the story, slow, even, unhurried. Allow your thoughts to settle like dust in still water. The universe has taken billions of years to reach this moment. You don't have to hurry through it. Let this be your escape into cosmic calm, a place where curiosity relaxes your mind, where wonder softens your body, and where sleep finds you naturally, the way light once found the early universe. Whenever you're ready, sink into the first chapter and let the quiet story of existence carry you. Most people imagine the universe beginning with noise, fire, and unstoppable force. But the true beginning felt more like a quiet pause before the first breath. In the beginning, there was no light, no movement, and no time. Picture a silent softness stretching endlessly, without direction or shape. This stillness was not empty. It was the gentle cradle holding everything that would one day exist. Imagine floating in a space so calm that even the idea of sound has not been invented yet. The mind naturally slows down in the silence, matching its peaceful rhythm. This quiet foundation allowed the universe to grow without rushing, without pressure, and without conflict. It waited patiently, as if gathering the courage to open its eyes for the first time. Let your thoughts drift across this early stillness, noticing how quiet can feel warm instead of cold, comforting instead of lonely. Even now, this original calmness exists within the background of everything. If you were placed in the pre-universe state, you wouldn't feel time passing at all because time itself had not started yet. If this moment of stillness relaxed you, consider subscribing for more calming science journeys. If the universe began in silence, how did the very first light appear without breaking it? The next section opens that gentle moment. The first light in the universe did not burst suddenly. It unfolded slowly, like the soft glow of morning spreading across a peaceful horizon. Imagine darkness stretching in every direction, calm and unbroken, when suddenly a warm, faint glow begins to bloom. It doesn't flash or roar. It simply arrives, drifting outward with patience. Early photons move gently through space, filling the universe with a subtle radiance rather than a violent blaze. This first light behaved more like a quiet awakening than a dramatic event. Picture a slow sunrise across a cosmic ocean, no rush, no urgency, only a gradual invitation to see. This soft illumination brought warmth to the universe for the first time, and even now, imagining it can ease tension from the mind. The glow moved like a lullaby across the darkness, guiding the universe forward with grace. Let yourself rest in that vision, a gentle light expanding through a quiet world, making room for everything to come next. Myth: the Big Bang produced a blinding flash of light. Reality: the universe remained dark long after the expansion. Light emerged later, slowly and softly. If this quiet dawn soothed you, consider liking the video to support more calming explorations. Light opened the universe gently. So how did space itself behave? The next section feels the universe stretching like a slow breath. Have you ever taken a deep breath and felt your chest expand softly? The universe once expanded with that same calming ease. Imagine space unfolding in every direction, not violently but smoothly, like fabric stretching under its own gentle weight. This expansion created room for everything that would one day take shape. Feel how peaceful it seems when space grows without force, without chaos. Early expansion behaved like a slow inhale, giving the cosmos its first sense of openness. Visualize yourself floating within that widening space, surrounded by softness and quiet movement. Nothing rushes, nothing commands urgency. The universe expands at a pace that feels natural, flowing, and almost meditative. This calm stretching allowed matter to travel freely, drifting into places where patterns would later form. The more you imagine this, the more your own breath begins to match the rhythm of cosmic expansion, a slow, deep, peaceful flow. This moment set the stage for structure, order, and future beauty. What do you think was the first thing to form after space stretched open? Share your guess in the comments to stay connected with this calming journey. If space stretched gently, what patterns appeared in that openness? The next section uncovers the universe's first delicate shapes. Before stars existed, the universe whispered its first patterns, subtle shapes forming with quiet rhythm across the early cosmos. As the universe cooled, slight variations in energy began shaping the first structures. These patterns were not sharp or geometric. They were more like smooth ripples drifting across a still lake. Imagine faint, cloud-like formations spreading softly, guiding matter without force. These patterns hinted at where galaxies would appear billions of years later. Their presence adds a gentle sense of order, like the universe humming a slow, steady melody beneath everything. Visualizing these soft shapes brings a feeling of centered calm, because the mind relaxes when it recognizes rhythm and flow. These early patterns were the universe's first attempt at structure, appearing not with noise but with quiet elegance. Let your thoughts drift through these cosmic ripples, noticing how each one creates a sense of gentle direction. These patterns were shaped by ancient sound waves, long, slow pressure waves moving through the early universe like a distant heartbeat. If these early patterns brought you calm, consider subscribing to stay part of this peaceful exploration. If patterns formed softly, what gathered around them next? The following section reveals the first cosmic clouds. Imagine a cloud so large and gentle that simply picturing it makes your mind feel lighter. That was the universe's very first cosmic cloud. As temperatures dropped, particles began drifting together, forming enormous clouds of hydrogen and helium. These clouds were not violent storms. They were soft, drifting structures stretching across unimaginable distances. Picture a calm, mist-like formation hovering in silent space, moving without wind or turbulence. These early clouds held the raw material for stars, yet at this stage, they were simply peaceful gatherings of matter, resting quietly while the universe continued to expand around them. Visualize a soft haze floating through darkness, shaping itself slowly like breath, forming a delicate mist. The stillness of these clouds created a sense of cosmic peace, a moment where gravity and silence work together with perfect gentleness. Myth: early nebulae were chaotic and violent. Reality: the first cosmic clouds were calm, stable, and remarkably quiet. If this imagery eased your thoughts, consider liking the video for more calming science stories. Inside these quiet clouds, the first stars would soon awaken. How does a star ignite without breaking the silence? The next section reveals that gentle birth. A star's birth sounds dramatic, but the universe's first stars awakened gently like a quiet spark glowing inside a vast, peaceful cloud. Imagine the silent cosmic cloud slowly gathering themselves, becoming denser at their centers. Deep inside, pressure begins to build softly, steadily, until the cloud warms from within. This warmth doesn't erupt, it glows. Picture a faint ember forming in total darkness, growing brighter at a calm, unhurried pace. Slowly, hydrogen begins to fuse, creating the first stable light the universe had ever seen. These early stars did not roar into existence. They whispered themselves awake, releasing a warm radiance into the cosmic night. Let yourself imagine that moment, a tiny glow floating inside an endless silent ocean of space. No explosions, no chaos, just the quiet ignition of a cosmic lantern. These first stars gently shaped their surroundings, calling nearby gas toward them with slow gravitational patience. Their steady light became the universe's first true illumination after ages of darkness. The first stars were much larger than most stars today, shining intensely but forming with remarkable smoothness. If this gentle starlight helped you relax, consider subscribing to continue this calming journey. If the first stars awakened softly, how did they begin shaping their surroundings? The next section explores their quiet influence. You might expect powerful stars to dominate their surroundings loudly, but the earliest stars shaped space with silent authority. Picture the newborn stars glowing steadily, their warm light spreading across the first cosmic clouds. Instead of violent blasts, these stars guided gas and dust with gentle radiation pressure, moving matter as softly as a slow breeze moves mist. Their gravity pulled nearby material into calm spirals, creating flowing shapes rather than sudden disruptions. Even when they released energy, the vast emptiness of space absorbed it quietly, turning intense processes into silent choreography. Imagine drifting near one of these stars, watching clouds swirl around it like soft ribbons around a lantern. These early stars also began forging heavier elements in their cores, creating the building blocks of planets, oceans, and life. Yet even this transformation unfolded silently. The universe at this stage was a place of glowing calm, slow movement, and patient change. Myth: early stars constantly erupted violently. Reality: while energetic, their effects spread quietly across enormous distances, creating more flow than chaos. If this silent cosmic shaping soothed you, consider liking the video to support more calming science explorations. As stars influenced their surroundings, new structures began forming around them. The next section reveals the first star clusters. Imagine groups of stars drifting together not with force, but with soft, gravitational pulling, like lanterns gathering in a slow-motion dance. As early stars formed, their Gravity reached out across space, inviting nearby stars into shared motion. These gatherings were not collisions, they were peaceful joinings. Picture dozens of faint glows drifting closer, aligning themselves into a quiet cosmic community. These early star clusters moved slowly, circling gently, their combined light creating warm patches across the ancient universe. Being part of a cluster offered stability. Stars supported each other's gravitational balance, creating zones of calm amidst expanding space. Visualize floating among them, each star shimmering gently, forming patterns that would guide the shapes of galaxies. The clusters had no rush. They simply gathered, breathed, and settled into rhythm. Their presence brought harmony to the early universe, providing structure without rigidity. Every cluster felt like an island of quiet companionship in a vast sea of darkness. Star clusters can stay gravitationally linked for billions of years, maintaining their gentle formations across time. If the image of drifting star communities eased your mind, consider subscribing for more cosmic calm. As clusters formed, the universe took an even greater step toward order. What came next shaped everything. The birth of the first galaxies. Galaxies seem massive and intense, but their first formations resembled slow spirals unfolding across a silent ocean. Imagine countless star clusters drifting closer under gravity, forming wide, swirling patterns that stretched across space. These early galaxies didn't snap into place. They grew gradually, like slow whirlpools forming in calm water. Picture stars gliding into gentle orbits, creating curves that looked almost painted. The universe's earliest galaxies had shapes that felt soft and flowing, not sharp or explosive. Their rotation created a soothing rhythm, a cosmic turning that guided the motion of stars for billions of years. Even now, imagining a galaxy spinning in quiet darkness encourages the mind to relax into its flow. These galaxies became the universe's large-scale architectures, yet they rose from simple, calm beginnings. Let the listener feel suspended inside a slowly turning spiral, drifting with its movement, becoming part of its elegant rotation. Myth. Galaxies formed suddenly. Reality. They emerged over long periods, gathering gently through slow gravitational choreography. If this spiral imagery brought you calm, consider liking the video to support these relaxing journeys. With galaxies forming, another mystery unfolds. How did the universe begin shaping the first planets? The next section opens that quiet chapter. Before planets existed, the universe made tiny, silent seeds, grains so small yet so important that they became the foundation of every world ever formed. Inside young galaxies, dust began gathering around newborn stars. Imagine tiny particles drifting through starlight, slowly sticking together with no noise, no pressure, no force. These grains clumped gently, forming pebbles, then stones, then larger bodies. Each step a quiet act of cosmic construction. Picture a soft swirl of dust moving around a star, glowing faintly as it orbits. Over millions of years, these calm gatherings grew into planet-forming disks. The universe built worlds the way a slow tide shapes sand, gradually, patiently, beautifully. There was no rush. Each tiny particle contributed calmly to something far greater. These early seeds would one day become planets, moons, oceans, mountains, and perhaps even life. But at this moment, they floated silently in warm starlight, waiting for their future shapes. Which do you think formed first? Rocky planets or giant gas planets? Share your guesses in the comments to stay connected with this cosmic journey. Now that planetary seeds exist, how do full planets emerge from this quiet swirl? Chapter 2 begins that story. When we imagine planets forming, we often picture chaos, collisions, and violent impacts. But in the beginning, planet formation felt more like a slow, gentle swirl. Imagine drifting around a young star where dust and gas float like soft mist. The light from the star warms this mist, making every particle shimmer as it circles peacefully. Over time, these particles begin drifting toward one another, not through force, but through gentle attraction. They stick quietly, forming delicate clusters that tumble slowly through space. Picture tiny grains gathering without any sound, like snowflakes settling on untouched ground. The star's gravity guides them into a wide, flowing disk, a soft halo that turns gracefully. This disk becomes the birthplace of future worlds. Nothing rushes here, nothing snaps into place, everything grows with patience. These early gatherings are small, fragile, and calm, yet they contain the promise of mountains, oceans, and atmospheres. The universe is shaping worlds, but doing so with the softness of drifting sand. Planet-forming disks can stretch for billions of miles, yet remain thin and quiet, like a cosmic sheet of dust. If this gentle swirl helped calm your mind, consider subscribing for more soothing cosmic stories. These soft clusters must grow into something larger. How does a pebble become a planet? The next section explores that quiet transformation. The earliest stages of planet building weren't dramatic. They were almost silent, like tiny stones gathering in a peaceful current. Imagine small dust grains joining to form pebbles, each connection happening quietly in the soft light of a young star. These pebbles drift around the star in slow orbits, brushing gently against one another. Each touch makes them slightly larger, slightly heavier. Over time, they become stones, then boulders, then massive chunks moving through space like quiet travelers. Picture these pieces floating peacefully, colliding softly because everything is cushioned by dust, gas, and enormous distances. No explosions, no sudden impacts, just slow building. Over millions of years, these growing bodies settle into orbits where they continue gathering material, becoming rounder and smoother. This gradual construction forms the early foundations of planets. If you could watch this process up close, you would see worlds taking shape one calm moment at a time. How long do you think it takes for a pebble-sized particle to become a mountain-sized body in space? Leave your guess in the comments to stay part of this peaceful journey. Once these bodies grow large enough, they begin to shape their surroundings. The next section reveals how. Gravity is usually imagined as a powerful force, but in the early universe, it worked softly, guiding matter with quiet patience. Picture a growing planetary body pulling nearby rocks and dust toward itself. Nothing slams together. Instead, gravity gathers material slowly, like a gentle hand shaping clay. The larger the body becomes, the stronger its pull, but the process still feels calm. Dust spirals inward, pebbles drift closer, and boulders settle into place over time. This soft gravity smooths the surfaces of young worlds, rounding them into spheres. Imagine floating near one of these early planets as material drifts toward it in graceful arcs, settling silently onto its surface. Every piece contributes to a calmer, more stable shape. Gravity isn't loud or dramatic here. It behaves like a steady breath, guiding each particle to where it belongs. Planets become round because gravity pulls evenly from all sides, smoothing their shape over long periods. If this quiet shaping brought you calm, consider liking the video to support more relaxing cosmic content. As planets grow, they begin clearing paths through their disks. How does that happen silently? The next section explains. A forming planet can carve a path through its disk, but it doesn't do it violently. It does it gently, like a boat gliding across a calm lake. Imagine a young planet orbiting its star, surrounded by dust and gas. As it moves, its soft gravity guides nearby material aside, creating a smooth channel. Nothing explodes or shatters. Particles simply drift around the planet's path, creating a cleaner and cleaner orbit over time. This process forms beautiful, ring-like gaps in the disk, patterns so calm and elegant that they look painted. The planet continues circling, and each orbit makes the path more defined. Picture yourself floating above this disk, watching the planet glide through it with quiet authority. These pathways help stabilize the planet's orbit and shape the disk into a structured environment where other bodies can grow. Everything happens slowly, steadily, and peacefully, creating order without disruption. Myth: young planets crash violently through disks. Reality: they shape their orbits gently, using gravity to guide material aside. If this quiet orbital shaping soothed your thoughts, consider subscribing for more calming cosmic chapters. Once planets clear their paths, they begin forming layers and identities. The next section explores how a world quietly becomes itself. A planet doesn't develop its layers through chaos. It forms them in slow, warming waves that move gently through its interior. Imagine a young planet growing heavier as more material settles onto its surface. This weight creates heat inside, but not the fierce kind you might imagine. It's a slow, deep warmth, like a glowing ember inside a stone. Over time, heavier materials sink toward the center, while lighter ones drift outward. This quiet sorting creates the planet's first layers. Picture the interior gently rearranging itself, settling into order the way sand naturally forms patterns on a calm beach. Nothing rushes, nothing snaps. The planet becomes structured through soft, patient movement. This layering determines its core, its mantle, its crust, everything that will shape its future landscapes. Even now, many planets continue adjusting their layers quietly, releasing heat in slow pulses. The layering process is called differentiation, and it happens because gravity encourages materials to settle where they naturally belong. If this calm planetary shaping brought you ease, consider liking the video for more soothing science stories. Once layers form, the planet's surface begins its quiet evolution. The next sections explore that silent transformation. When a young planet cools, it doesn't harden suddenly. It cools the way evening settles over a quiet landscape, slowly, gently, and without any sound. Imagine a young world glowing faintly with inner warmth. Its surface slowly begins to change as the heat escapes into space. The cooling doesn't crack or snap. It spreads like calm air drifting over warm ground. The surface begins forming solid crust as minerals settle into place. Picture soft waves of temperature lowering across the planet, creating a stable shell where future features will rise. In this peaceful stage, the world feels almost like a sleeping ember, warm inside, quiet outside. Over millions of years, small ridges and shallow basins form not through violence, but through gradual shifting. This early crust becomes the foundation for everything the planet will one day hold. mountains, oceans, atmospheres, none of them exist yet, but their stage is being prepared in gentle silence. The cooling process shapes the planet's character, influencing what it might become: a rocky world, a watery world, or a barren, quiet sphere drifting in space. Even Earth once cooled under a glowing shell of vapor before forming its first solid crust. If this calm cooling process relaxed your mind, consider subscribing for more peaceful cosmic storytelling. After cooling, planets start interacting with their star's light. The next section explores this gentle illumination. Before atmospheres and oceans existed, starlight alone shaped young planets, quietly warming them, guiding them, and giving them their first sense of rhythm. Imagine a planet freshly formed, its surface smooth and quiet, slowly turning beneath the soft glow of its star. Starlight falls gently across one side, while the other remains in peaceful darkness. This slow alternation begins the planet's first day and night cycle, even before life or weather. The light warms some areas more than others, encouraging subtle movements in the crust, mild shifts in minerals, and early temperature gradients. Nothing dramatic, just a planet learning the rhythm of light and shadow. Picture standing on such a world, feeling the warmth of a young sun spreading across a silent landscape, then watching darkness glide in softly as the planet turns. Over time, starlight helps determine which worlds stay warm enough for oceans, which remain cold, and which transform into gas giants. It is a quiet sculptor, shaping worlds through gentle illumination. Myth: starlight instantly creates dramatic changes on young planets. Reality: starlight works slowly, influencing worlds over long, calm periods. If the idea of starlight shaping worlds soothed you, consider liking the video for more calming science journeys. With light guiding the planet, something else begins to appear: a thin, early atmosphere. The next section reveals its quiet beginning. An atmosphere doesn't arrive in a rush. It forms like a soft veil rising from the planet itself. Imagine a young planet with a warm interior and a cooling crust. Light gases begin drifting upward from inside the planet, rising gently into space. These gases don't burst out. They seep, they float, they gather. Over time, they form a thin, delicate layer around the world. Picture a pale mist slowly wrapping itself around the planet, barely visible, yet essential. This first atmosphere is simple, made of gases released by the planet's own heat. It provides insulation, softening temperature swings, and creating a calmer environment for future changes. The planet now breathes in its own quiet way, releasing gases upward and letting them drift outward before gravity gently pulls them back. Even on rocky planets, this early atmosphere acts like a protective whisper, preparing the world for more complex layers to develop. Earth's first atmosphere was nothing like today's. It was thin, hot, and made mostly of hydrogen and helium. If this soft atmospheric formation eased your thoughts, consider subscribing for more calming cosmic lessons. Once a planet gains even a thin atmosphere, something remarkable can begin: early weather. The next section explores this silent change. Weather didn't begin with storms or winds. It began with barely noticeable motions. Soft temperature shift moving gently across young worlds. Imagine a thin atmosphere warming slightly under starlight. Some parts heat a bit faster, others cool more slowly. These differences create the first small movements of air. Picture faint currents drifting across a silent surface like warm breath passing through cool air. Over time, these tiny motions form patterns, gentle flows that circle the planet. This is the birth of weather, not chaotic or threatening, but subtle and calm. These early atmospheric motions help shape the planet's landscape, smoothing rough areas and carrying gases from place to place. Weather begins as a whisper, long before it ever becomes wind or rain. Even now, imagining such soft flows can bring a sense of comfort, as if the planet is breathing peacefully beneath its star. What do you think formed first? Clouds or winds? Share your guess in the comments to stay engaged with this calming journey. As weather quietly begins, the next transformation becomes possible: the rise of early oceans. The coming section reveals this gentle change. Oceans didn't appear suddenly. They formed through slow cooling and quiet condensation, like mist settling into gentle pools. Imagine a young planet with a thin atmosphere and a warm surface. As the world cools further, water vapor begins to gather in the air, not in storms, but in soft, drifting clouds. These clouds release moisture slowly, drop by drop, over millions of years. Picture rain falling so gently that it feels like a steady whisper across the planet's surface. This moisture collects in low regions, forming small lakes, then larger basins, and eventually vast oceans. These early waters are warm, calm, and shallow, covering the planet in a soft blue glow. Oceans transform a world into something alive with possibility, even if life has not yet begun. The surface becomes smoother, cooler, and more stable, ready for the next chapter of cosmic evolution. Some planets may form oceans entirely from atmospheric condensation, without any icy comets involved. If this quiet formation of oceans felt soothing, consider liking the video for more calming cosmic chapters. Now that oceans exist, how does a planet begin shaping continents and mountains? Chapter 3 begins that silent evolution. Most people imagine continents forming through violent upheaval, but in the earliest stages, the process felt more like slow rising breaths beneath a quiet ocean. Imagine a young planet covered mostly in warm, shallow water. Deep below the surface, heat moves softly through the mantle, creating gentle swells. These swells push solid crust upward, not abruptly, but gradually, like soft hills emerging beneath a blanket. Over millions of years, certain regions lift higher than others, slowly rising out of the ancient seas. Picture wide, smooth land masses merging through mist, forming the planet's first primitive continents. The surface is still quiet, the air is thin, and the landscape is simple: stone, calm water, and early light. Nothing shatters, nothing bursts. Continents arrive the way islands appear in dreams, slowly, silently, naturally. These first land masses will one day shape rivers, winds, climates, and life itself. But for now, they simply rest at the surface, creating the planet's earliest boundaries. Earth's first continents were small and fragile, made mostly of lightweight minerals that floated on the mantle like rafts. If this slow rise of continents soothed your imagination, consider subscribing for more calming cosmic scenes. As land begins to rise, the deep interior continues shifting. The next section reveals how the planet starts breathing from within. A planet's interior moves constantly, but not with explosion or chaos. It moves like a slow, deep breath that shapes the world from below. Imagine heat rising gently from the core, traveling upward in wide, slow currents. These currents push the mantle in soft cycles, causing the crust above to drift. Picture massive plates floating on a sea of warm rock, moving so gradually that a lifetime would not reveal even a single mile of change. Yet these motions are powerful over long stretches of time, guiding continents, raising mountains, and forming new oceans. The planet behaves almost like a living being, exhaling warmth upward and inhaling cooler material downward. This cycle of motion, so slow it feels still, creates the conditions for landscapes to evolve. Imagine standing on this early world and sensing the faint, steady hum beneath your feet. Nothing shakes, nothing cracks suddenly. The planet breathes in silence, shaping itself in a rhythm older than life. Do you think continents move faster, slower, or about the same pace today compared to the early planet? Share your guess in the comments to stay part of this peaceful journey. As the interior breath continues, the land above begins forming new shapes. The next section explores the quiet birth of mountains. Mountains may look dramatic, but their creation begins quietly, an ancient process that unfolds slower than any imaginable sunrise. Imagine two massive plates drifting toward each other, not quickly, but at the speed your fingernails grow. When they meet, the crust gently folds upward, layer by layer, creating the earliest ridges. Picture stone rising the way dough rises in warm air, gradual, soft, patient. These early mountains are low at first, rounded and smooth, shaped by long ages of gentle uplift. Over millions of years, they grow taller, their peaks forming slowly as pressure continues. Even the planet's first great ranges formed without violence, guided by steady forces beneath. Imagine standing near one of these ancient slopes, watching the horizon lift so gradually that only the passage of eons reveals its shape. Mountains become the planet's anchors, influencing wind, weather, rivers, and ecosystems, even long before life begins. Some mountain ranges rise only a few centimeters each year, yet can eventually reach heights of thousands of meters. If the quiet rise of mountains helped calm your thoughts, consider liking the video for more soothing science stories. As mountains form, other forces begin reshaping the surface from above. The next section reveals how rivers begin in silence. Before rivers roared or rushed, they began as soft threads of water quietly finding their way across new land. Imagine early rain falling on a warm, rocky surface, gathering slowly in shallow depressions. Over time, these small pools overflow, forming delicate streams that wander across the new terrain. Picture water moving so gently that it feels like a whisper sliding over stone. These early streams carve barely noticeable paths, returning again and again until tiny grooves become small channels. Millions of years pass, and these channels deepen into rivers, still calm, still steady, shaping the planet drop by drop. There is no hurry. The water simply follows gravity, creating curves, valleys, and basins. Rivers become the planet's quiet sculptors, guiding landscapes and carrying minerals across continents. They prepare the surface for future ecosystems by smoothing rough edges and forming gentle plains. Myth: early rivers were violent and fast. Reality: they began slowly, shaped by soft rainfall and steady flow. If this peaceful river formation eased your mind, consider subscribing for more calming journeys. As rivers form, oceans also begin to shift the land. The next section explores this gentle interaction. The meeting of land and ocean seems powerful today, but in the beginning, It was a slow, soft dance that shaped coastlines with patience. Imagine gentle waves brushing against newly formed continents. These early waves were not strong. They rolled softly across the surface, spreading warmth and minerals. Over time, they smoothed rough shores, rounding edges and forming bays, inlets, and long, curving coastlines. Picture water meeting land the way a calm tide touches sand, quiet, steady, and rhythmic. The oceans do not rush the process. They shape coastlines through millions of soft touches, each wave leaving a small imprint. These interactions also help regulate temperature, creating balanced climates along the edges of continents. Even now, the planet's coastlines are shaped more by gentle persistence than sudden change. Imagine standing on one of these early shores, watching the horizon shimmer as soft waves create the first patterns along the land's edge. This process prepares the surface for future weather systems, ecosystems, and life. Early oceans were much warmer than today and covered far more of the planet's surface. If this image of quiet coastlines soothed you, consider liking the video to support more relaxing science storytelling. As oceans shape the land, the sky above begins transforming as well. Section 6 opens the next stage of the planet's quiet evolution. A planet's sky didn't suddenly turn blue or cloudy. It transformed softly, layer by layer, like a gentle curtain rising into place. Imagine a young world with a thin atmosphere hovering lightly above its surface. As volcanic gases rise slowly from deep within the planet, they mix with existing air, creating thicker layers. Picture delicate veils of gas wrapping the planet one strand at a time. Over long ages, sunlight begins reacting with these gases, altering their colors, creating soft hazes. The sky shifts in tone gradually, from pale gray to warmer hues, then into the first hints of soft blue. This early transformation happens without storms or wind. It is a quiet chemistry shaping the planet's identity. Even now, if you imagine looking up at this early sky, you would see a peaceful gradient stretching from horizon to horizon, untouched and calm. The atmosphere grows steady and supportive, capable of holding moisture, balancing temperature, and preparing the world for deeper change. The sky's first colors were likely soft red or orange due to volcanic gases scattering sunlight differently than today. If this image of a sky forming softly brought you calm, consider subscribing for more soothing cosmic journeys. As the sky thickens, sunlight begins behaving differently across the planet. The next section reveals how gentle light shapes early climates. Before storms and seasons, climates began with quiet sunlight warming different parts of the world at different times. Imagine the planet slowly turning beneath its star. One side warms in calm light, while the other cools under quiet shadow. This simple rhythm begins shaping temperature patterns across the surface. Over time, these gentle temperature differences create the first soft climate zones. Some areas stay warm, others cool more quickly, and some remain balanced between the two. Picture a world where sunlight drifts across landscapes without intensity, slowly teaching the planet how to respond. The atmosphere absorbs and releases heat in a steady flow, creating peaceful cycles. Early climates weren't dramatic. They were predictable, smooth, and slow, setting the stage for wind, clouds, and rainfall to evolve. These calm beginnings would one day create fertile grounds for life. But for now, they simply bring order to the planet. Which do you think formed first? Seasonal cycles or large climate zones? Share your guess in the comments to stay engaged with this peaceful journey. As climates form, clouds begin gathering more consistently. The next section explores how clouds arrived in gentle silence. Clouds didn't appear with thunder or storms. They began as soft wisps of moisture rising into a calm and cooling sky. Imagine warm water from early oceans slowly evaporating into the atmosphere. As the vapor drifts upward, it cools gently, forming tiny droplets that float like fine mist. These droplets gather quietly, forming delicate streaks across the sky. Picture the first clouds appearing as thin, pale veils, so faint you could almost see through them. Over time, these threads of moisture thicken, creating wider patches that drift slowly across the horizon. There is no thunder yet, no lightning, just silent bodies of water suspended in air. These clouds help regulate temperature, shielding the surface from harsh sunlight and releasing gentle rain. They also begin the long partnership between water and sky, shaping the planet's weather through quiet cycles. Watching these early clouds would feel like watching breath form in cool morning air, soft, fleeting, peaceful. Early clouds were likely much higher and thinner than today's clouds because the young atmosphere was still developing. If imagining these first clouds brought you ease, consider liking the video for more calming science stories. Once clouds form, rainfall becomes more regular. The next section reveals how early rains reshaped the world. Rain began long before storms. It started as a slow, steady fall, soft droplets returning to the planet with quiet persistence. Imagine moisture gathering in thin clouds high above the surface. As droplets grow heavy, they drift downward gently, falling through a calm sky. The early raindrops are warm, small, and spread far apart. They land softly, forming shimmering layers on rock and soil. Over time, the rain becomes more consistent, shaping small grooves in the land, deepening channels created by earlier flows. Picture millions of years passing as patient rainfall smooths rough terrain and brings minerals into the oceans. The process is slow and delicate, yet profound. Rain introduces the planet's first true cycles of renewal, connecting sky, land, and ocean. Even now, imagining early rainfall evokes a sense of calm, a quiet reminder of nature's gentle persistence. Myth: the first rains were violent storms. Reality: they began as soft precipitation, guided by a thin, peaceful atmosphere. If this moment of quiet rainfall soothed you, consider subscribing for more relaxing explorations. With rainfall shaping the ground, lakes and rivers begin expanding. The next section explores their gentle growth. The world's first lakes and rivers didn't burst into existence. They expanded slowly, fed by patient rainfall and the gentle pull of gravity. Imagine water collecting in low areas, forming shallow pools that glimmer in early sunlight. As rain continues, these pools grow wider, deeper, and more connected. Streams link them together, guiding water calmly across the land. Picture lakes forming like mirrors laid across the surface, still reflective, peaceful. Over ages, rivers lengthen and broaden, tracing their way through valleys shaped by quiet erosion. These bodies of water regulate temperature, nourish landscapes, and prepare the surface for future life. Their growth is subtle but steady, a reminder that transformation often comes through patience. Standing at the edge of an early lake would feel like witnessing a world discovering its own reflection. Some of Earth's earliest lakes existed for millions of years before life ever reached them. If this gentle expansion of lakes and rivers relaxed you, consider liking the video for more soothing science chapters. Now that land, sky, and water are working together, the stage is set for an even deeper transformation. Chapter 4 begins that quiet evolution. Before life could appear, a planet had to cool into a peaceful balance. A temperature soft enough to protect, yet warm enough to support possibility. Imagine the world surrounded by quiet oceans, calm winds, and a slowly stabilizing sky. Over millions of years, volcanic activity softens, the crust strengthens, and the air grows more steady. Picture the surface settling into gentle rhythms of day and night, warm sunlight, followed by cool darkness. These stable patterns allow water to remain liquid, climates to calm, and coastlines to take their shape. The planet becomes neither too hot nor too cold, but finds a quiet middle ground, a delicate balance essential for life to begin. Imagine standing on this early world, feeling a mild breeze moving over water, warmed softly by the star above. The atmosphere thickens just enough to shield the surface while letting in the gentle rays that guide biological beginnings. This peaceful environment forms the foundation for chemistry to evolve into something more. Life on Earth may have begun during a time when the planet's temperature was similar to a warm spring day. If this balanced world brought calm to your imagination, consider subscribing for more soothing cosmic stories. Once the world becomes stable, the first building blocks of life gather quietly. The next section explores their gentle formation. Life didn't begin with lightning strikes or sudden sparks. It began with tiny molecules drifting together in peaceful water. Imagine warm, shallow oceans filled with simple chemicals. Carbon, nitrogen, hydrogen, all moving softly through the currents. These molecules bump into one another gently, forming slightly larger structures with each calm interaction. Picture countless tiny pieces floating in warm pools, combining slowly and naturally. No noise, no pressure, just patient chemistry occurring in silence. Over long periods, some combinations become more stable than others, forming chains and clusters that can store information and energy. These early structures drift along the surface, guided by soft waves and mild sunlight. The ocean becomes a quiet laboratory where life's first ingredients gather, mix, separate, and recombine. Everything happens gradually, like a whispered invitation toward complexity. These simple molecules are the ancestors of every organism that will ever exist. Their formation marks the beginning of biological potential. Where do you think life's first ingredients formed? Deep oceans or shallow coastal pools? Share your guess in the comments to stay part of this calming journey. As ingredients gather, something remarkable happens. They begin organizing themselves. The next section reveals that quiet step. Before life could exist, molecules had to learn one simple behavior: how to arrange themselves gently into patterns. Imagine small molecular chains drifting in warm water. Some fold naturally into shapes that help them stay together longer. Others attract new molecules that strengthen their structure. Picture these early patterns forming like soft threads weaving into simple fabrics. Nothing is forced. Everything arranges through natural chemistry and quiet repetition. Over time, these organized structures become better at holding energy, communicating with nearby molecules, and maintaining their shape. Think of them as early whispers of life, still simple, still silent, but beginning to behave with purpose. Tiny membranes form, creating soft boundaries that separate inside from outside. These early compartments drift through water like microscopic bubbles, protecting delicate chemical reactions within. The planet's calm environment allows these structures to survive long enough to grow more complex. This gentle organization is one of the most important steps in life's evolution. Some scientists believe early molecules could copy themselves without any enzymes, just naturally guided by water and heat. If this quiet step toward organization helped you relax, consider liking the video for more soothing science chapters. As structures organize, something even more delicate begins: self-replication. The next section explores that silent milestone. Life truly begins when a structure learns to make a gentle copy of itself, and the first copies were incredibly slow and quiet. Imagine a simple molecule floating in warm, calm water. When the conditions are just right, it attracts similar pieces that attach themselves in the same order. Slowly, a second version forms alongside the first. No energy bursts, no sudden reactions. Just a patient process of matching shapes. Picture two strands drifting together, connected only by the natural tendency of their parts to align. These early copies are imperfect, but those imperfections inspire variation, a key ingredient for evolution. The planet's tranquil environment gives these molecules time to repeat the process, creating generations of structures that gradually improve. Self-replication marks the moment when chemistry becomes something more than reaction. It becomes persistence. It becomes continuity. It becomes the first whisper of life on a quiet world. Myth: the first life copied itself rapidly. Reality: early replication was extremely slow, taking place over long, peaceful intervals. If this gentle beginning of replication calmed your thoughts, consider subscribing for more relaxing science stories. Once replication begins, competition and cooperation quietly arise. The next section opens that phase. Even before complex life existed, tiny molecules learned that survival was easier when they worked together softly. Imagine early replicating molecules drifting in shallow pools. Some accidentally protect each other, forming clusters that survive longer. Picture small chains gathering like gentle teams, sharing energy and supporting each other's reactions. These groups grow slowly, forming networks that perform simple tasks better than any single molecule could. Over time, cooperation becomes a quiet advantage. The planet's calm environment allows these networks to persist, gradually learning to store energy, share resources, and build protective shells. These early collaborations mark the first step towards cells, tiny communities held together by silent partnership. No conflict, no competition yet, only mutual benefit, shaped by the soft rhythms of water and heat. Some scientists think cooperation emerged before true competition, making early life surprisingly peaceful. If this idea of early cooperation soothed you, consider liking the video to support more calming science explanations. With cooperation established, the next major step emerges quietly: the birth of the first true cells. Chapter 4 continues with that transformation. The first cells didn't appear with complexity or struggle. They formed like quiet bubbles, rising in warm, gentle water. Imagine early cooperative molecules drifting together inside delicate membranes. Over time, these membranes grow stronger, forming soft boundaries that protect everything inside. Picture tiny spheres floating peacefully in shallow oceans, each one carrying a simple chemical world within it. These early cells are fragile, but their surroundings are calm enough for them to survive. Inside, reactions unfold slowly, storing energy, copying information, and managing resources. Nothing inside a cell is hurried. Everything runs at a steady, natural rhythm. These tiny compartments become the planet's first true living units. Simple, silent, patient. Imagine millions of these cells drifting beneath the gentle surface of early oceans, forming a quiet community that blankets the world. They are small, but they represent the first major burst of biological structure. The earliest cells were likely so small that thousands could fit on the tip of a sewing needle. If picturing these calm, floating cells relaxed your mind, consider subscribing for more peaceful science storytelling. Once cells appear, the next quiet transformation begins, learning to gather energy from their world. The next section reveals how. Before complex metabolism existed, the first cells survived by absorbing gentle flows of energy from their surroundings. Imagine a single cell drifting near warm underwater vents or resting in sunlight. Instead of hunting or competing, it simply absorbs the mild heat or chemical gradients around it. Picture these cells gathering energy as softly as mist absorbing light. Some cells take in small molecules dissolved in water, slowly breaking them down for nourishment. Others rely on warmth to power their internal reactions. The entire process feels passive, quiet, and steady. Nothing like the active metabolism we see today. These early energy systems allowed cells to survive without movement or pressure. They simply floated where conditions were right, letting nature feed them softly. This calm method of gathering energy created the foundation for more complex metabolism to evolve later. Do you think early cells used sunlight or chemical energy first? Share your answer in the comments to stay part of this peaceful exploration. As cells master energy gathering, some begin sharing it. The next section explores the quiet rise of early teamwork. Some of the earliest breakthroughs in life happened not through conflict, but through peaceful cooperation between simple cells. Imagine two different cells drifting close together. One is good at capturing energy. Another is good at processing nutrients. Instead of competing, they begin to share. Picture one cell taking shelter inside another, not as an invader, but as a quiet partner. Over time, this relationship becomes so stable that the inner cell becomes a permanent helper, eventually evolving into structures like mitochondria, tiny engines of energy within modern cells. This peaceful collaboration allowed life to grow more efficient without needing strength or speed. Cooperation becomes a pathway to complexity, shaping life's evolution through patient alliances rather than force. Imagine these early pairs drifting peacefully through the ocean, forming the first complex cells through quiet partnership. Your cells contain ancient remnants of these early partnerships, still working peacefully inside you today. If this story of quiet cooperation brought you calm, consider liking the video for more soothing science chapters. As teamwork evolves, cells begin to change their environments. The next section reveals that soft influence. Long before life grew visible, tiny cells were already reshaping the world, softly, gradually, and without any noise. Imagine millions of primitive cells drifting in oceans, releasing small amounts of gas as they gather energy. These gases rise into the atmosphere and slowly begin to alter its composition. Picture oxygen forming gently in the air, not as a sudden burst, but as a soft, continuous addition. This gradual change influences temperature, weather, and ocean chemistry. Over ages, the planet becomes more stable, cooler, and more supportive of complexity. These silent changes transform the world into a place where more advanced life will one day thrive. It is remarkable to imagine that the quiet breath of tiny cells shaped an entire planet. Early life may have taken hundreds of millions of years to produce enough oxygen for major environmental change. If this silent planetary transformation soothed your imagination, consider subscribing for more calming cosmic stories. As life changes the planet, new environments open. The next section reveals how early ecosystems formed quietly. Life didn't spread in large leaps. It formed tiny, peaceful communities where cells gathered in places rich with gentle resources. Imagine shallow pools warmed by sunlight, with clusters of cells drifting together. Some float near the surface, gathering light. Others settle near warm sediments, absorbing nutrients. Picture these small groups forming quiet layers, thin films on rocks, soft mats in tidal zones, drifting patches in calm waters. These early ecosystems are simple, yet stable. They share resources, create balance, and influence their surroundings with delicate regularity. Over time, these communities grow, covering rocks, sands, and coastlines, turning lifeless surfaces into gentle networks of interaction. These ecosystems evolve slowly, building structure without noise or pressure. They prepare the world for even greater complexity to come. Some early microbial mats still exist today and are considered living fossils. If visualizing these peaceful early ecosystems calmed your thoughts, consider liking the video to support this journey. With ecosystems forming, life is ready for its next quiet transformation. Chapter 5 begins that story. Life didn't expand in explosions or sudden bursts. It spread like a soft glow moving across a calm landscape. Imagine early cells drifting in oceans, forming gentle communities along coastlines and shallow seas. Over millions of years, currents carry these simple organisms farther, settling them in new environments. Picture life spreading the way morning light spreads across a quiet valley, slowly, evenly, with no force. Cells adapt gradually, finding comfort in warm pools, calm tides, and gentle underwater plains. They drift into deeper waters, cling softly to rocks, and form delicate films across sediments. This gradual expansion turns scattered pockets of life into a connected web. Imagine an entire planet slowly becoming alive, not loudly, but through countless quiet movements. Every new place life reaches becomes slightly transformed, more stable, more balanced, more prepared for change. The world begins to feel inhabited, even though nothing has yet grown large enough to see with the naked eye. Life spreads through patience, not power. Early life covered Earth for more than 1 billion years before anything complex appeared. If this calm spreading of life soothed your imagination, consider subscribing for more peaceful cosmic storytelling. As life spreads, it begins to change form in subtle ways. The next section explores how complexity begins in silence. The leap from simple to complex life didn't happen suddenly. It unfolded like a slow unfolding of petals in a quiet garden. Imagine early cells drifting in calm waters. Over ages, some cells begin forming internal structures, tiny compartments that help them store energy, process nutrients, and protect themselves. Picture these cells growing slightly larger, their inner spaces becoming more organized, like soft rooms forming within a house. These early complex cells, known as eukaryotes, are gentle advancements rather than abrupt changes. Their new capabilities allow them to survive in varied environments and to interact with other cells in more sophisticated ways. Imagine clusters of these cells forming small cooperative patches beneath soft sunlight. Their emergence marks a new chapter for life, but it remains patient, slow, and quiet. Complexity arrives not through struggle, but through opportunity. Do you think complex cells appeared in shallow water or deeper regions first? Share your guess in the comments to stay engaged with this peaceful journey. Once complex cells exist, the next step is even more surprising. Cells learning to join together. The next section reveals that moment. Before plants or animals existed, life learned a simple lesson. Two cells together could survive more easily than one. Imagine complex cells drifting in warm water. Sometimes they remain near each other after dividing, forming tiny groups. These groups gradually learn to share nutrients and divide tasks, creating the first multicellular clusters. Picture small, jelly-like shapes floating peacefully, each cell contributing quietly to the whole. Over time, these clusters grow larger and more organized, taking on simple forms: layers, spheres, and filaments. Nothing about this process is rushed. Multicellularity arises through gentle cooperation, not competition. These early organisms move slowly, respond softly to light and nutrients, and drift through calm waters like silent lanterns. They represent life's first attempt at building something bigger than a single cell. Some modern microscopic organisms still behave like early multicellular life, living as simple groups that work together. If imagining the first multicellular forms brought you peace, consider liking the video for more relaxing science stories. As cells learn to unite, they begin to specialize. The next section explores this quiet division of labor. Life's first great innovation was not speed or strength. It was the quiet realization that different cells could do different tasks. Imagine a cluster of cells floating together. Over time, some cells absorb more nutrients, others sense light, and still others protect the outer edges. Picture this early teamwork forming naturally, like individuals in a group settling into roles without being asked. These early roles improve survival, making the organism more stable and efficient. Nothing forces this change. It emerges through gentle benefits, repeated over generations. Soon, these organisms develop simple tissues, soft layers of cells performing shared functions. The world's first biological division of labor takes shape not through command, but through peaceful cooperation. Myth: early multicellular life was already specialized. Reality: specialization emerged slowly, starting with simple tendencies among cells. If this soft rise of specialization relaxed your thoughts, consider subscribing for more calming knowledge. With specialization in place, life begins shaping forms. The next section explores how the first simple body shapes appeared. Before creatures swam or crawled, life experimented with shape. Soft spheres, gentle tubes, and simple layers drifting in silent oceans. Imagine early multicellular organisms forming natural curves and folds as they grow. Some become hollow spheres, others flatten into sheets. Some stretch into tiny tubes. Picture these soft forms drifting in calm water, responding gently to light and nutrients. These shapes allow life to absorb more energy, move slightly more efficiently, and interact with the environment in new ways. The evolution of form is slow and graceful, shaped by water currents and gentle pressures. Nothing about these organisms is rigid. They bend softly, grow gradually, and drift like delicate balloons beneath the waves. These early shapes become the foundation for all future bodies. Branches, limbs, shells, and wings will all trace their ancestry back to these quiet beginnings. For now, the world is filled with soft geometry moving through warm oceans. Some of the earliest shapes in life still exist today in simple marine organisms. If these early forms brought calm to your imagination, consider liking the video to support more peaceful science storytelling. As shapes evolve, movement begins. The next section in Chapter 5 reveals life's first gentle motions. Before swimming or crawling existed, the earliest movements were simple ripples, soft motions shaped by quiet water. Imagine small, soft-bodied organisms drifting in calm oceans. At first, they move only when currents carry them. But over time, some begin to contract their bodies slightly, creating gentle pulses. Picture these tiny pulses spreading through the water like slow waves. They aren't fast or forceful. They're just enough to adjust direction or stay near sunlight. This is life's first attempt at motion, delicate, rhythmic, barely noticeable. These early movements help organisms find warmth, avoid darkness, and gather nutrients more effectively. Some bend softly, others wiggle faintly, and some simply float with more control. Nothing is hurried. Each movement is a quiet step toward future locomotion. Imagine an entire underwater world where life shifts in slow, graceful motions, creating a peaceful ballet. These gentle movements mark the beginning of all future mobility. Do you think early movement began for finding food or escaping danger? Leave your guess in the comments to stay connected with this calming journey. As motion improves, life begins to sense the world around it. The next section reveals how early sensing evolved softly. Long before eyes or ears existed, simple life learned to feel the world through gentle signals in water. Imagine early organisms drifting in mild currents. Some begin to respond to slight changes, warmer temperatures, subtle chemicals, or soft shifts in light. Picture cells that glow faintly when light touches them, or change direction when nutrients drift nearby. These aren't true senses yet, but they are early whispers of awareness. Over time, these responses become more refined. Organisms move toward warmth, away from harmful substances, or toward brighter areas where food is more abundant. This quiet awareness shapes the way life interacts with its environment. The world becomes not just a place to float through, but a place to notice, to respond to, and to gently explore. These first senses guide future evolution, laying the groundwork for sight, smell, taste, and touch, all beginning from soft reactions in a calm ocean. Some simple organisms today still sense light, using tiny patches that act like primitive eyes. If this soft rise of early senses soothed your imagination, consider liking the video for more peaceful science stories. As sensing evolves, life begins to explore new environments. The next section reveals how early organisms spread into deeper waters. As senses improved, early organisms began drifting into deeper, calmer regions of the ocean, like explorers moving into quiet, untouched worlds. Imagine shallow seas glowing under sunlight. Now picture organisms slowly drifting downward, following soft gradients of temperature and nutrients. Deeper waters are cooler, darker, and more peaceful. Movement here is gentle, and the environment changes gradually. Early life explores these depths not through bravery or speed, but through slow adaptation. Some organisms learn to survive with less light. Others find new nutrients drifting in deep currents. Picture small, soft-bodied forms gliding downward like falling petals, resting where conditions feel balanced. This exploration expands life's territory, allowing diversity to take root. The deeper ocean becomes a sanctuary, a place of quiet evolution where life experiments with new forms and strategies. Myth: early life stayed only in sunlit waters. Reality: life slowly expanded into deeper regions as soon as simple senses allowed it. If imagining this slow exploration brought calm to your thoughts, consider subscribing for more soothing cosmic chapters. As life fills deeper waters, competition and cooperation begin shaping evolution. The next section explores this gentle shift. Life didn't suddenly start fighting for survival. Early competition appeared more like gentle balancing than conflict. Imagine different organisms drifting near each other in calm oceans. Some gather nutrients more effectively, while others survive better in dimmer conditions. This creates soft pressures that guide evolution. Picture an environment where organisms simply do what they do best, not battling, but coexisting in shift and harmony. Over time, certain traits become more common because they offer small advantages. Meanwhile, cooperation remains essential. Organisms still depend on shared resources, shared spaces, and stable communities. This balance of mild competition and gentle collaboration leads to diversity. Evolution at this stage is slow, peaceful, and patient, a quiet shaping of life based on opportunity rather than conflict. In many ecosystems today, cooperation is as common as competition, echoing early evolutionary patterns. If this peaceful picture of early evolution helped you relax, consider liking the video to support more calming science storytelling. As diversity grows, life begins creating visible patterns. The next section reveals the soft emergence of early ecosystem structure. Before forests or coral reefs existed, life arranged itself into quiet patterns. Simple, gentle structures forming across calm waters. Imagine thin layers of organisms growing across rocks, forming soft carpets beneath shallow seas. Others float in vertical columns, rising and sinking with gentle temperature shifts. Picture delicate bands of life forming where light is strongest, creating natural gradients of color and activity. These quiet patterns become the first ecosystems with structure. Zones of light dwellers, shadow dwellers, surface floaters, and deep settlers. Each group shapes the environment slightly, filtering water, releasing gases, and stabilizing sediments. Over time, these interactions create a peaceful balance where every region supports the next. The world becomes not just alive, but organized, softly, slowly, beautifully. Some of these ancient ecosystem patterns still exist in modern microbial mats found in quiet coastal areas. If these early patterns relaxed your thoughts, consider subscribing for more soothing cosmic journeys. With ecosystems now structured, life is ready for even deeper transformation. Chapter 6 begins that quiet evolution. Life's next changes weren't sudden leaps, they were soft expansions, gentle steps toward new possibilities, guided by calm oceans and steady rhythms. Imagine early multicellular organisms drifting across quiet seas. Over long ages, they begin forming slightly more complex tissues, shapes, and behaviors. Picture small clusters gaining structure, their bodies folding gently into new patterns. Nothing about this transformation is loud. It happens slowly, like a soft melody adding new notes. These organisms take advantage of stable climates, clean waters, and the gentle cycles of light. Some begin growing slightly larger, others develop delicate extensions that help them sense their surroundings more clearly. Complexity rises not through pressure, but through opportunity. Each tiny improvement allows the organism to survive a bit longer or explore a bit farther. Imagine entire coastlines filled with soft-bodied forms, each one an experiment in quiet evolution. Life is getting ready for vastly more diverse shapes, but it begins here, calmly, patiently, beautifully. Some early complex organisms grew only a few millimeters over their entire lives, yet laid the foundation for larger creatures. If this peaceful expansion of life soothed your imagination, consider subscribing for more calming science journeys. As complexity grows, life begins to interact with the environment in new ways. The next section explores this shift. For the first time, life didn't just exist in the world. It began shaping it softly through movement, feeding, and quiet exploration. Imagine early organisms spreading across soft sediments, leaving faint trails behind them. These trails change how water flows, how nutrients settle, and how communities form. Picture these gentle interactions creating new textures on the ocean floor. Some organisms stir the sediment slightly as they move, others create small pockets where water collects differently. These tiny actions influence the stability of ecosystems, helping nutrients circulate more efficiently. Imagine watching these organisms glide slowly over the seabed, adjusting to their surroundings while also adjusting the surroundings themselves. Life becomes not just a passenger on the planet, but a soft sculptor. These quiet interactions build the foundation for more complex ecosystems, where organisms will depend on each other's roles and movements. Do you think early life shaped the ocean floor more through movement or through chemical activity? Share your guess in the comments to stay engaged with this peaceful journey. As life influences its world, new forms of feeding evolve. The next section reveals how early nourishment began. Before hunting or grazing existed, life fed in the simplest, quietest ways, absorbing nutrients as gently as a sponge takes in water. Imagine early organisms drifting through nutrient-rich waters. Instead of grabbing or biting, they simply absorb dissolved chemicals through their soft surfaces. Picture cells in small multicellular forms feeding without motion, letting nutrients naturally flow toward them. Over time, some organisms develop tiny folds or channels that help capture nutrients more efficiently. These structures appear gradually, like ripples forming in sand. This gentle feeding method allows life to grow larger and more diverse without strain. In calm waters, organisms settle where nutrients flow steadily, forming peaceful feeding grounds. Imagine a world filled with drifting, absorbing, slowly nourishing life. No competition, no chasing, just quiet sustenance. Some modern organisms still feed this way, using passive absorption shaped by ancient evolutionary strategies. If this soft approach to nourishment brought you calm, consider liking the video to support more soothing science storytelling. As feeding becomes more efficient, life begins forming new shapes to support growth. The next section explores this gentle shift. As life took in more energy, it began developing new shapes, not suddenly, but through delicate extensions and soft modifications. Imagine a simple organism forming a small flap to increase its surface area, helping it absorb more nutrients. Picture another forming a thin branch-like structure, drifting gently to catch currents. These changes appear slowly, shaped by billions of tiny advantages repeated over ages. Life begins experimenting with form, creating soft limbs, simple tentacles, and thin sheets. None of these structures are strong yet, but they don't need to be. Calm oceans support them effortlessly. These early features help organisms anchor themselves, move softly, or gather more energy from the environment. Over time, these gentle innovations lead to broader diversity. Imagine a peaceful underwater garden filled with early shapes swaying softly in the currents. Myth: body structures evolved quickly. Reality: they formed gradually through countless small changes across millions of years. If these gentle early forms relaxed your imagination, consider subscribing for more calming knowledge. As structures evolve, life becomes more mobile. The next section reveals the beginning of quiet, purposeful motion. Long before fast swimming existed, life learned to move with intention. Soft pulses and subtle contractions guiding direction. Imagine an organism gently contracting part of its body, moving a tiny distance toward a warm patch of sunlight. Another bends softly, steering itself toward an area rich in nutrients. Picture these movements as slow and deliberate, like quiet stretches through still water. These early motions help organisms position themselves better, avoid unfavorable conditions, and explore new areas. Purposeful motion doesn't start with speed or strength. It begins with gentle nudges toward opportunity. Over time, these motions become more refined. Organisms develop simple muscles, tiny fibers, and coordinated pulses. Life becomes more dynamic, while still remaining peaceful. Imagine these early creatures drifting with intention, moving like soft shadows across the seabed. Some early organisms used simple waves of contraction that traveled along their bodies, creating smooth, gliding motion. If this early motion soothed your thoughts, consider liking the video for more calm, science-based storytelling. With motion improving, life prepares for its next great expansion. The next section continues the quiet evolution of movement. Movement did not begin with speed, it began with softness, gentle waves of motion spreading through early life like calm ripples. Imagine oceans filled with simple organisms drifting gracefully. Some push the water slightly with tender strokes. Others glide through it by shifting their bodies in slow waves. Picture these early motions as a silent dance across ancient seas. Nothing is frantic. Every movement is measured, smooth, and guided by soft currents. As organisms become more confident, they explore new depths and new regions, discovering quiet places rich in nutrients. Movement becomes not just a tool, but a gentle form of exploration. Some organisms begin to coordinate their motions, creating simple rhythms that help them travel farther. Others use soft pulses to escape dim areas and return to gentle light. This expansion of motion reshapes entire ecosystems, allowing life to spread into environments that were once unreachable. Which do you think evolved first? Gliding motions or pulsing motions? Share your guess in the comments to stay engaged with this calming journey. As movement spreads, life begins forming new strategies for survival. The next section explores these early adaptations. Before hiding or hunting existed, survival began with subtle adjustments, soft behaviors shaped by peaceful oceans. Imagine early organisms learning to settle where light is mild or drifting to spots where nutrients gently collect. These simple choices become the first survival strategies. Picture organisms that change their shape slightly to blend into soft sediments, or those that move just enough to avoid harmful chemicals. These behaviors are slow, instinctive, and delicate. Nothing dramatic. Over millions of years, these quiet strategies help life persist through gentle challenges. Changes in temperature, shifts in currents, or small fluctuations in available resources. Survival becomes a calm, balancing act, guided by opportunity rather than conflict. These early strategies form the foundation for more complex behaviors that will evolve later. Some modern microorganisms still use primitive survival strategies nearly identical to those of ancient life. If these subtle strategies soothed your imagination, consider liking the video for more peaceful science stories. As survival improves, life begins building shapes for stability. The next section reveals the quiet rise of early support structures. Before bones or shells existed, life developed gentle supports, soft frameworks that helped early organisms hold their shape. Imagine simple multicellular organisms growing slightly sturdier. Some develop internal fibers, thin and flexible, that help maintain form. Picture these early supports as delicate threads running through soft bodies, giving them stability without rigidity. These structures allow organisms to grow larger, withstand mild currents, and move with more control. Think of them as the universe's first experiments in architecture, fragile, elegant, and perfectly suited to calm seas. Over time, these supports branch, strengthen, and diversify, laying the groundwork for future skeletons and shells. But for now, everything remains soft, quiet frameworks in a quiet world. Myth: early organisms needed strong support to survive. Reality: gentle supports were enough because early oceans were calm and protective. If imagining these soft internal structures brought you peace, consider subscribing for more calming evolutionary stories. As supportive structures evolve, life becomes ready for new environments. The next section explores this gentle expansion. With improved movement and support, early organisms began drifting into unfamiliar regions, entering new habitats with soft exploration. Imagine shallow coastal areas teeming with early life. Now picture some organisms gently floating toward deeper waters, others drifting into quieter tidal zones, and some settling along sheltered reefs. This expansion happens gradually, guided by mild currents and slow adaptation. Each new environment offers slightly different conditions: cooler temperatures, softer sediments, dimmer light. Life responds quietly, adjusting shape, movement, and feeding strategies. This gentle expansion increases diversity and allows ecosystems to flourish. Imagine a world where life spreads softly across every corner of the ocean, creating new layers of complexity with each step. Many early organisms occupied multiple habitats throughout their life cycles, drifting between environments as conditions changed. If this peaceful expansion soothed your thoughts, consider liking the video to support more calming journeys. As life spreads, interactions grow more meaningful. The next section reveals the quiet rise of ecological relationships. Long before ecosystems became complex, early organisms formed quiet relationships, simple exchanges that shaped the future of life. Imagine two organisms drifting near each other. One releases oxygen, another absorbs it. One provides nutrients, another helps recycle them. These interactions arise naturally, without intention or competition. Picture gentle exchanges happening across calm waters, forming the first ecological bonds. Some organisms settle near others that create favorable conditions. Some cluster in areas where others generate shade or warmth. Slowly, communities begin to form. Groups of organisms connected through subtle, peaceful relationships. These early interactions help stabilize environments, regulate resources, and encourage diversity. Ecosystems begin to behave like soft networks, each part contributing quietly to the whole. Even the simplest ecosystems rely on interactions that began in ancient oceans billions of years ago. If these peaceful early relationships brought you calm, consider subscribing for more soothing evolutionary stories. With relationships forming, life is prepared for its next silent transformation. Chapter 7 begins that journey. When diversity began to rise on Earth, it didn't explode suddenly. It unfolded slowly like new colors spreading across a calm ocean. Imagine early seas filled with simple shapes, soft bodies drifting gently, each one slightly different from the next. Over time, small variations begin appearing, a slightly longer filament, a softer curve, a new way of feeding. Picture these subtle differences accumulating quietly across millions of years. No competition, no dramatic bursts, just gentle branching of life's possibilities. Each new variation forms because the environment offers space to explore. Some organisms grow larger, others stay tiny. Some move toward light, others settle in the coolness below. Imagine the ocean as a vast canvas where life paints itself slowly, adding new patterns with each generation. Diversity rises naturally, the way ripples interact on still water. This growing variety makes ecosystems more balanced, stable, and resilient. Every organism contributes its own quiet presence to the world's developing harmony. Most of Earth's early diversity existed only in microorganisms, long before larger creatures appeared. If this gentle rise of diversity calmed your imagination, consider subscribing for more soothing science storytelling. As life diversifies, new environments emerge for exploration. The next section reveals this silent expansion. Before life conquered the world, it first learned how to settle into small, quiet spaces called niches. Imagine calm oceans with countless microenvironments, warm, shallow pools, cool, shaded trenches, soft sediments, nutrient-rich surfaces. Early organisms begin drifting into these areas, finding places where they survive just a little more comfortably. Picture small forms settling into warm patches or collecting near mineral-rich rocks. Over time, each niche becomes home to a different type of organism. Some prefer dim light, others thrive near gentle ocean currents. This quiet occupation reduces competition and increases stability. Life spreads not through force, but through discovery. Imagine life softly filling every available space, forming a mosaic of tiny worlds within the larger one. These niches become the early foundations for ecosystems that will one day host all forms of life we know. Do you think early niches formed more in shallow waters or deeper seas? As niches form, life begins to specialize. The next section explores this gentle refinement. Life's first specializations were not dramatic shifts, they were quiet improvements. Tiny adjustments that helped organisms fit their niches better. Imagine early organisms that move slightly more efficiently toward light, or those that absorb nutrients just a bit more effectively. Over long periods, these small advantages accumulate. Picture bodies shaped subtly for specific roles. Thin forms drifting in open water, rounded forms resting on sediments, branching forms reaching for light. Nothing changes overnight. Specialization is like a whisper shaping life's direction, guiding organisms toward their best possibilities. These gentle adjustments allow life to divide into groups with different strengths, increasing diversity and stability. Imagine each organism as a note in a growing symphony, adding richness through quiet differentiation. Some of the earliest specializations still exist in modern microorganisms that occupy very specific environmental niches. If this gentle refinement helped you relax, consider liking the video for more calming evolutionary stories. As specialization increases, life begins forming early networks. The next section reveals these soft connections. Before food webs or ecosystems existed, life formed simple, quiet networks, patterns of interaction that supported everyone involved. Imagine organisms releasing nutrients into the water as they grow. Nearby organisms absorb those nutrients, creating a soft cycle of exchange. Picture tiny communities that depend on one another without even touching. Some organisms produce oxygen, others use it. Some break down materials, others feed on the byproducts. These networks grow slowly, forming balanced systems where each part contributes quietly. Imagine floating through early oceans and sensing invisible lines connecting everything around you. These early networks create resilience. If one group grows or fades, the others adjust gently. Life begins to function as a collective even before true ecosystems appear. Myth: early ecosystems were chaotic. Reality: they formed through gentle interactions that increased stability. If this quiet web of early life soothed your thoughts, consider subscribing for more peaceful science journeys. With networks forming, life is ready for a major shift: the development of more complex body plans. The next section begins that silent transformation. The roots of complex creatures began not with sudden innovation, but with simple patterns quietly repeating and refining. Imagine early multicellular organisms with soft repeating segments or gentle folds in their bodies. Over time, these patterns become more organized. Picture symmetrical shapes forming naturally, left and right sides balancing softly, front and back beginnings emerging like early landmarks. These structural hints allow future organisms to develop organized bodies with specialized regions. Nothing here is rigid. Everything remains soft and gradual. These foundational patterns become the blueprint for muscles, limbs, organs, and eventually entire body systems. Imagine early life drifting with gentle order, the universe experimenting patiently with new forms. Even the simplest symmetrical organisms today share traits with these ancient early body plans. If imagining the origins of complex forms felt calming, consider liking the video for more soothing evolutionary storytelling. With body plans forming quietly, life prepares for one of the greatest transitions ever. Section 6 begins that shift. Complex movement didn't begin as fast swimming or crawling. It began as soft rhythms, gentle waves of coordination shaping early bodies. Imagine early organisms with simple body plans learning to move in slightly more organized ways. Some contract their segments in smooth sequences. Others ripple their soft tissues to glide through water. Picture these movements as quiet patterns spreading through the body like slow music. Over time, the patterns become more refined. Organisms learn to pulse forward with purpose, to turn gracefully, to rise or sink through subtle adjustments. Nothing is forceful. Every movement is guided by rhythm and calm repetition. These early motion patterns help organisms reach new environments, avoid harsh conditions, and follow gentle nutrient flows. Imagine the ocean floor dotted with creatures drifting like soft shadows, each one guided by a new level of coordination. These silent innovations are the ancestors of every muscle, every limb, and every swimming stroke that will ever evolve. Some of Earth's earliest complex movement patterns still exist in modern jelly-like organisms that pulse through water. If this gentle rise of movement soothed your imagination, consider liking the video for more silent, evolutionary journeys. As movement patterns grow, life begins responding more deeply to the world. The next section reveals this quiet sensitivity. Before eyes or ears appeared, organisms developed faint senses, subtle ways to feel the world's quiet signals. Imagine early creatures drifting through calm waters. They begin responding not just to light or chemicals, but to pressure changes, gentle vibrations, and faint currents. Picture organisms sensing the direction of flow by how water brushes against their surfaces. Some feel the warmth of sunlight in specific areas of their bodies. Others detect slight movements nearby. These sensations guide their soft motion patterns, helping them avoid danger, find nutrients, and settle in comfortable environments. Nothing is sharp or dramatic. Sensory awareness grows like fog, lifting slowly, expanding, revealing more of the world with each improvement. Over time, these early senses become more coordinated, connecting to movement in gentle loops, sensing, responding, adjusting. Imagine a world where creatures glide with awareness, feeling the ocean whisper around them. Which sense do you think evolved first, light sensitivity or vibration sensitivity? Share your guess in the comments to stay engaged with this peaceful evolution. With senses deepening, life begins exploring new strategies. The next section uncovers those quiet innovations. Evolution's greatest breakthroughs often began as tiny, gentle changes, almost invisible shifts that slowly transformed life. Imagine organisms developing slight stiffening in their tissues, allowing them to hold their shape better. Picture others forming thin, protective layers to shield themselves from mild environmental changes. Some begin storing energy more efficiently, letting them move farther with less effort. These innovations appear gradually, repeating over generations until they become standard features. None of them are dramatic on their own, but together they create new pathways for evolution. This is how life advances, not through leaps, but through soft steps. Each improvement adds a bit more strength, stability, or opportunity. Imagine the oceans filling with creatures that are just a little better adapted, drifting calmly as they explore these new capabilities. Many evolutionary innovations first appeared in very small organisms long before they reached larger forms. If these gentle evolutionary steps brought calm to your thoughts, consider subscribing for more soothing science journeys. As innovations grow, life begins forming simple communities. The next section explores these early groupings. Even before true social behavior evolved, some organisms discovered that staying close together brought quiet benefits. Imagine small creatures drifting in gentle clusters. They don't communicate or coordinate yet. They simply settle near each other because conditions feel right. These groupings offer subtle advantages: more stable temperatures, easier nutrient sharing, and gentle protection from environmental changes. Picture hundreds of small organisms forming calm clouds beneath the surface, moving together as currents shift. Over time, these gatherings become more structured. Some organisms take positions nearer the light, while others stay in deeper layers. These natural groupings shape early ecosystems and open pathways for future social evolution. Everything happens softly, driven by simple tendencies to remain near helpful conditions. Myth: cooperation evolved only in complex creatures. Reality: early life formed quiet groupings long before true social behavior appeared. If this peaceful picture of early communities relaxed you, consider liking the video to support more calming knowledge. With group living taking shape, the final step of this chapter begins, life preparing for larger, more visible forms. The next section opens that shift. Before life grew into forms we could see, the planet quietly prepared through subtle environmental and biological changes. Imagine oceans becoming clearer as ecosystems stabilize, nutrients spread more evenly, currents soften, and temperatures settle into reliable patterns. At the same time, organisms refine their movements, senses, structures, and energy systems. Picture early multicellular forms growing slightly larger, not suddenly, but through slow accumulation of advantages. The world becomes a more supportive place for bigger bodies, oxygen increases, food webs strengthen, and ecosystems become balanced enough to sustain greater complexity. These shifts happen silently, setting the stage for the first visible creatures to appear. It's like the universe holding its breath gently, preparing for a new chapter of life. Oxygen levels had to reach a specific threshold before larger organisms could evolve comfortably. If this calm preparation for visible life soothed your imagination, consider subscribing for more peaceful evolutionary storytelling. You've drifted through the quiet history of the universe, through soft light, gentle oceans, and the patient rise of life. And now, as the story settles, let your breath slow with it. This calm belongs to you. If this journey helped you feel lighter, quieter, or more at peace, I invite you to stay connected with these stories. Your support keeps this space alive. When you subscribe, like the video, or share it with someone who needs rest, you help build a place where calm is always waiting. Every action you take tells the platform that you want more moments like this. And it makes it easier for others to discover them too. If you're still awake, leave a comment with the moment that relaxed you the most. If you drifted off along the way, simply write "completed" when you return. These small actions mean more than you know. They help this calm reach far beyond tonight. But now you can let go again. Let the echoes of this journey fade into the background of your thoughts. Let your breath settle. Let sleep come to you softly, the way starlight once arrived in the early universe. Thank you for listening, for resting, for being here. Whenever you need calm, you know where to return. Good night.